After reviewing the initial settings required for our TRIOS scanner in the first two videos and exploring the benefits of using an initial scan as a study model, today we will demonstrate how to use the TRIOS scanner to get an impression of a single natural tooth abutment. As always, I will provide practical tips you can apply in your daily clinical practice. TRIOS scanners have the option of being wireless, or they can use a wired connection. If you have a wired TRIOS, my advice is to plug the network cable connected to the scanner directly into the network socket of the PC. In case there is no network outlet on the PC and you need to use a USB adapter, always verify the speed of the USB ports. Even when using the same type of USB sockets, two different ports might have varying speeds. Therefore, my recommendation is to consistently assess the speed and performance when using the scanner. It is crucial to check the speed of USB ports, especially if you are using them, as it can significantly impact the performance of the intraoral scanner. As I explained in the previous video, it is very important to do the calibration of the intraoral scanner every morning. This will positively affect the performance of the scanner itself. After creating the patient profile, we will click on the New Case button and select the recipient for our scan, in this instance our Canale Lab in Rimini. We will then prepare our prescription, specifying which tooth requires the crown. Since today's scan involves a single abutment natural tooth, which happens to be a second molar, tooth number 17, we will select that tooth. Next, we need to inform the scanner about the type of restoration we intend to perform. By clicking on the first anatomy button, we will indicate that it is a crown. We would modify this setting if we were creating an inlay, an onlay, or a veneer. But for this case, it's a crown. We are using monolithic zirconia as the material, although you can see there are various material options available based on prescription requirements. Subsequently, we can indicate the tooth's color, although this is not mandatory. If necessary, we can provide additional color information to the laboratory. In this specific case, we are selecting shade A3. Now, we specify the desired delivery date, which we have set as a couple of weeks from the current date. The prescription details we just configured are displayed for reference. There's an option to perform pre-preparation involving scanning of the provisional restoration. However, this is part of the reverse workflow procedure, which I will demonstrate in a future video when we create an impression for an implant-supported single crown. For this particular case involving tooth 17th, we won't be implementing scanning of the provisional. Nonetheless, we can include initial prescription information that we want to send to our laboratory. In this specific case, I will simply state single crown on 16th. Monolithic. In zirconia. Cast free. So I complete to my liking what is the initial prescription. Later I can add photos, and I will do that to possibly give a shade indications by clicking this button that says Add. At this point we go ahead with our digital workflow and start taking our scans. I recommend one thing that I'm sure you all know. Never to use the light from the dental unit when scanning, because this can affect the performance of the scanner. And even from this point of view, there is scientific literature that shows how ambient lights can affect the performance of our scanner. Let's start with the antagonist scan. I remind you how the scanning technique that I recommend is always the oscillatory technique. So you take the cusp slopes, Listen to how well the scanner works just from the noise and finalize the antagonist scan. Well, having finished the antagonist scan, we check it and proceed to clean up the excess tissue. Once you have made the biggest trims, just click on the first button. Automatically, the scanner software will go and clean these excesses. Once the antagonist is taken, we move on to the next step. Following what is the normal flow of the scanner software, and we are going to scan the upper arch. We have to scan the upper arch, so we will proceed to rotate the tip so that we have the Scan Start button positioned in a more ergonomic and easy way. We do not remove the provisional at this time, but take the scan of the arch on which the abutment is to be taken with the provisional in place. The upper arch is easier because we do not have the tongue. After scanning the occlusal incisal part of the arch with the oscillatory movement I showed you, I will go to scan the buccal and palatine part. A cleaning of the impression from the soft tissues. At this point, we're going to trim the abutment that we're going to scan that has the interim restoration in situ. Well, now as you see, we have trimmed the tooth with provisional, and we will remove the interim restoration and decide the type of gingival retraction that we like best. We could clearly use the double cord Udelis technique, or as I prefer, in the posterior areas. And as we published in an article in the Journal of Prosthetic Dentistry, I use the interim restoration itself to condition and dislocate the gingiva, so that we then have an easy, quick and accurate impression with the intraoral scanner. So the two gingival dislocation techniques that we can use are the one using retractor cord, or the one, as I was telling you, with the provisional. I prefer the posterior areas, this one, so I remove the interim restoration from the patient's mouth, clean the abutment. From the cement, we go to reinsert the provisional crown that dislocate the gingiva. We hold it down and proceed to scan the abutment without the provisional, by removing the crown a few seconds before bringing the scanner tip closer. The provisional has been left in place for 4 or 5 minutes. We remove it, we go to clean up the abutment quickly. And we start with the selective scan of the prosthetic abutment. So as you can see, in very few seconds, once the provisional is removed, the tissue doesn't have time to collapse, and we have time to be able to detect the prosthetic abutment with the hard tissue part within the gingival sulcus. We're going to indicate the abutment that we scanned because the workflow is asking us to do that. The abutment is second molar, and at this point we're ready to detect the bite scan. The TRIOS software gives us the ability to detect bite registration on both the right and left. Let's have the patient close the mouth. We check that the occlusal contacts are the correct ones, and we proceed to scan the right side, reminding the patient not to move, not to make any movement. The software with this noise tells me that he has already positioned the two arches, but I continue and go and scan more teeth with the bite scan. This will be able to give more information about what is the patient's occlusion to our lab. Once the alignment is completed, we will move to the left side, have the patient open her mouth again, then close it again, check that the occlusion, and go to scan the left side. Always reminding the patient not to move from this position, even if assistant and dentist pull and move their lips apart, because this may cause the patient to make some movements. After capturing both bite scans, it's important to assess the interocclusal space. While it may seem like there is ample space between the abutment and the opposing tooth, it's crucial to utilize the tools available in the TRIOS software to conduct a thorough and precise examination of the interocclusal space. Let's proceed by clicking on the clearance button to verify the clearances or spaces between the abutment and the opposing arch. As I demonstrated in the previous video, the colors represent the amount of space available. When we are in the red and orange zones, the space measures around 0.7 to 0.8 millimeters. As we transition into the yellow-green zone, we exceed 1 millimeter of space. Now let's examine our abutment, and I can confidently say that we have more than sufficient space to create the restoration we requested from the lab, which is a monolithic zirconia crown. If in this region we were to detect a red or orange color, indicating inadequate space, there would be no need to retake the scans entirely. Instead, we would simply trim the occlusal portion of the abutment or the entire abutment in the occlusal area and then rescan only the single abutment. As you can see, this approach offers a significant advantage compared to the traditional method of using impression pastes, as it avoids the need to rescan the entire arch. So the occlusal spaces are absolutely correct. We proceed and go on to detect the dynamic occlusion, I mean the jaw movements of the patient. After identifying the static occlusion, the next step is to detect the dynamic occlusion. It's crucial to instruct the patient on the specific movements we are going to assess. For detailed guidance on how to instruct the patient in performing mandibular movements accurately, please refer to the previous video where I explained the maneuvers in depth. In this case, the patient has already been briefed on what she needs to do, so we can proceed with dynamic occlusion detection. The scanner should be placed in the areas marked by the blue bands that you can see on the initial screen. These are the regions of occlusion that it has identified. The scanner will then automatically recognize the movements as soon as we begin with the dynamic occlusion assessment. Open, close. We put the scanner in the mouth, and the patient knows that she will have to start the movements only when we tell her to start, and she will have to follow our instructions very precisely without going too fast or too slow. Slide forward slowly back. Slides to the right. Goes backward. Slides to the left. Back. Back. Okay. In this case, the left lateral mandibular movement was not recorded because you noticed that the scanner at some point stopped, so it was no longer making noises. In this case, what I do is I go back to recording the whole dynamic. I delete the scan. We go back to the patient-specific motion screenshot and we go back. Please open. Close. Slide forward, slowly come back. Right? Go back. Left stop, go back. Perfect. Detected the patient-specific motion. Let's go to check and verify that everything is okay. Remember that this type of mandibular movements can be used by laboratory only if it has the 3Shape dental system software. Let's go at this point to the analysis screen, in which we will proceed to post-processing. First of all, let's go to check what the teeth shade are. And let's start giving our lab some information about the shade. Let's click on an adjacent tooth area. In the buccal area, we can add as many extra shade as we want. We take the incisal area and in this way, our lab will have a kind of shade map of the adjacent tooth that we can use to give an indication of what is the abutment shade. Well, we have observed how we can assess the occlusal clearances for our tooth preparation and make adjustments without the need to retake the entire impression. Instead, we can simply trim the abutment. In this screenshot, for instance, we can provide specific instructions to the technician regarding the design of the preparation. We can outline the preparation line, which will serve as a guideline for the technician. It's important to note that the technician can still make modifications as needed. The level of detail and magnification available in this situation is something that is simply not feasible with traditional analog impressions. This kind of magnification, this kind of control, is a real revolution in what concerns digital dentistry. As you see, we have the capability to mark the tooth finishing line and provide specific instructions to our laboratory. These instructions will be sent to the laboratory, but they are not obligated to adhere strictly to these finishing line. The laboratory can make adjustments according to their expertise and judgment. However, we can offer valuable guidance and insights when we deem it necessary. We can check again the occlusal spaces. On this analysis page, we can make annotations so we can give indications, for example, on a particular area, on a papilla, on a gingival margin. So we go and click and write, for example, pay attention. To the papilla. So we are going to point a very specific area within our scan by giving hints or making annotations. Well, let's proceed to post-processing, so let's click post-processing. And at this point, our scanner processes all the information and the scans that we have made and gets ready to send them to our lab. The post-processing is finished and we are ready to send our scan for the fabrication of a single crown on a natural tooth, and more specifically, a monolithic zirconia without the production of the model. Before sending the skins, I go back to the initial settings and I go to upload a photograph. to attach a photo and add a clinical photo, which will clearly be the one of the tooth shade. I have inserted the memory card of the camera in the PC, and as you see in the list of scans and files that we are going to send to the lab, there will be the antagonist, there will be the master scan, and there will be the bite scan. Furthermore, if we have entered some information in the comments section, they will be available here. You can see here the shade information and the last file is the clinical image with the Vita shade guide. With all this information attached, the lab will be able to proceed with the fabrication of our monolithic zirconia crown. As the last step, we then go to send the file to the lab. We have concluded this video tutorial on using the TRIOS scanner to get a scan to make a single crown on a natural tooth. In the following video tutorial, we will explore the workflow and procedures for scanning a single implant to make an implant-supported single crown.